Example of steady state processes, turbines. A turbine is a rotary steady state steady state machine whose purpose is to produce shaft work, power on a rate basis, or power or on rate basis at the expense of the pressure of the working flow. The pressure of the working flow. Working fluid. Two general classes of turbines are steam turbines steam turbines in which the steam exists. The turbine passes to a condenser. The steam exists in the turbine. Passes to a condenser. Where it is condensed to liquid. And gas turbines in which the gas usually exhausts to the atmosphere. Exhaust to the atmosphere. From the turbine. In either type, the turbine exit pressure is fixed by the environment into which the working fluid is housed. The turbine exit pressure is environment. Excuse me. So we have P equals to the atmosphere or P0 or P infinity. Maybe it depends on the problem. In either type, the turbine exit pressure is fixed by the environment in which the working fluid exists, and the turbine inlet pressure has been reached by previously pumping or compressing the working fluid is another process, and the turbine inlet pressure equals to the outlet pressure of the previous inline device, such as pump or compressor. Inside the turbine, there are two distinct processes. In the first, the working fluid passing through a set of nozzle or the equivalent fixed blade passage control. So in the turbine, the first process is working fluid passes through a set of nozzle or the equivalent fixed blade blades passage contoured to the expand to the fluid to a lower pressure. Passage to a lower pressure and high velocity. In the second process inside the turbine, this high velocity fluid stream is directed onto a set of moving blades. This high velocity fluid stream is directed onto a set of moving blades. In which the velocity is reduced before being discharged from the passage. The velocity decreases before leaving the passage. This directed velocity decreases produces a torque. So is directly So we have two processes that decrease the velocity. We can calculate that this directed velocity decrease produces a torque on the rotating shaft resulting in shaft work output. In shaft work output, the low velocity, low pressure fluid then exhausts from the turbine. The low velocity and low pressure fluid then exhausts from the turbine. The first law of this process in either usually change in potential energy are negligible. So we have negligible potential energy so delta PE equals to 0 as is the inlet kinetic energy and PI inlet kinetic energy equals to 0. Often the exit kinetic energy is neglected and any heat rejection from the turbine is undesirable and is commonly small. And any heat rejection Q equals to 0 for a steady state turbine. So the first law plus GZI Q0 0 and this difference is 0. We have also the outlet velocity, but we can write the work is HI minus HE, or in the extensive HE kilojoule, and it is kilojoule on kilograms. The first law for turbine. We therefore normally assume that the turbine process is automatic and the work output in this case reduces to the decrease in enthalpy from the inlet to exit, as shown in this relation. In the example about the turbines in the example video part 2, further observation can be made referring to this example. Also description are available. The next section is compressor and pumps.